Okay, my name is Debonik. This is Mastering Electronics Lab number 4. Today we are building circuits using operational amplifiers. So if you take a look at our circuit board, we have 3 different setups for operational amplifiers. The first one we have is an inverting amplifier. So basically what that does is that amplifies a signal but inverts it. So what that means is that there will be a phase shift of 180 degrees. We use 2 resistors. This is R1 right here, and then this is R2 right here, so R1, R2, and R1 is connected to our input voltage, and then R2 is connected, the R2 input of, the R2 is connected to the input of the op-amp, connects the input of the op-amp to the output of the op-amp. And these 2 wires are the input and output voltages, so we use plus and minus 15 volts. Our next circuit is a voltage follower circuit. So a voltage follower circuit, as you can see, has no resistors, and what that does is that just amplifies the signal. So this wire connects the input of the op-amp to the output, and then what we would have done is we would have taken the voltage inputs and connected them into the 2 middle pins of this op-amp with the same plus and minus 15 volts. Now, if you look at our last one, this is a directional amplifier. Differential amplifier, not directional. Differential amplifier. So what this does is this amplifies the difference between 2 voltage inputs. So basically we have, these are R1 and R3 with the equal magnitude of resistance, and here's R2 and R4 with equal magnitude of resistance. Then we have 2 inputs this time, which are 2 inputs which are connected to both of these resistors, and then R4 is connected back to ground, and R2 is connected from the input of the amplifier to the output. So now if we look at okay, so this is the experimental data for the inverting amplifier. So the first thing that we measured was the slew rate. So the slew rate of the inverting amplifier was 0.692 volts per microsecond. Using these waves, we also were able to verify the gain. So the gain is simply the output voltage over the input voltage. So the output voltage is channel 2, the input voltage is channel 1. So as you can see, it's really easy to find the gain using this graph. This waveform is for the differential amplifier. So using this waveform, we're able to find the common mode gain. So the way we find the common mode gain is you simply have to measure the peak-to-peak voltage of the square wave that is on channel 2, so this really small wave here, and divide that by the common mode gain of channel 1, and that gives you, the peak-to-peak voltage of channel 1, and that gives you the overall common mode gain.